Hey guys. This is Space Train, your daily express till the edge of the space, and today we will talk about what is dark energy. Grab your tickets and let's go. Don't forget to subscribe to get unlimited pass on our expedition. Looking up at the night sky reveals a small piece of the cosmos, patches of stars speckled across a dark, black void. Though the universe appears stationary to the naked eye, it is expanding at an increasing rate, with the distance between galaxies doubling every 10 billion years. Scientists attribute this phenomenon to dark energy. In the early 1990s, one thing was fairly certain about the expansion of the universe. It might have enough energy density to stop its expansion and recollapse. It might have so little energy density that it would never stop expanding, but gravity was certain to slow the expansion as time went on. Granted, the slowing had not been observed, but, theoretically, the universe had to slow. The universe is full of matter and the attractive force of gravity pulls all matter together. Then came 1998 and the Hubble Space Telescope, HST, observations of very distant supernova that showed that, a long time ago, the universe was actually expanding more slowly than it is today. So the expansion of the universe has not been slowing due to gravity, as everyone thought, it has been accelerating. No one expected this, no one knew how to explain it. But something was causing it. Eventually theorists came up with three sorts of explanations. Maybe it was a result of a long-discarded version of Einstein's theory of gravity, one that contained what was called a cosmological constant. Maybe there was some strange kind of energy fluid that filled space. Maybe there is something wrong with Einstein's theory of gravity and a new theory could include some kind of field that creates this cosmic acceleration. Theorists still don't know what the correct explanation is, but they have given the solution a name. It is called dark energy. Dark energy is sometimes confused with the similarly mysterious dark matter, though the two are separate entities. We will talk about it in our next video. Make sure you follow our content. So let's go back to question, what is the dark energy? More is unknown than is known. We know how much dark energy there is because we know how it affects the universe's expansion. Other than that, it is a complete mystery. But it is an important mystery. It turns out that roughly 68% of the universe is dark energy. Dark matter makes up about 27%. The rest, everything on Earth, everything ever observed with all of our instruments, all normal matter, adds up to less than 5% of the universe. Come to think of it, maybe it shouldn't be called normal matter at all, since it is such a small fraction of the universe. One explanation for dark energy is that it is a property of space. Albert Einstein was the first person to realize that empty space is not nothing. Space has amazing properties, many of which are just beginning to be understood. The first property that Einstein discovered is that it is possible for more space to come into existence. Then one version of Einstein's gravity theory, the version that contains a cosmological constant, makes a second prediction: empty space can possess its own energy. Because this energy is a property of space itself, it would not be diluted as space expands. As more space comes into existence, more of this energy of space would appear. As a result, this form of energy would cause the universe to expand faster and faster. Unfortunately, no one understands why the cosmological constant should even be there, much less why it would have exactly the right value to cause the observed acceleration of the universe. Another explanation for how space acquires energy comes from the quantum theory of matter. In this theory, empty space is actually full of temporary, virtual, particles that continually form and then disappear. But when physicists tried to calculate how much energy this would give empty space, the answer came out wrong. Wrong by a lot. The number came out 10,120 times too big. That's a 1 with 120 zeros after it. It's hard to get an answer that bad. So the mystery continues. Another explanation for dark energy is that it is a new kind of dynamical energy fluid or field. something that fills all of space, but something whose effect on the expansion of the universe is the opposite of that of matter and normal energy. Some theorists have named this quintessence, after the fifth element of the Greek philosophers. But, if quintessence is the answer, we still don't know what it is like, what it interacts with, or why it exists. So the mystery continues. A last possibility is that Einstein's theory of gravity is not correct. That would not only affect the expansion of the universe, but it would also affect the way that normal matter in galaxies and clusters of galaxies behaved. This fact would provide a way to decide if the solution to the dark energy problem is a new gravity theory or not. We could observe how galaxies come together in clusters. But if it does turn out that a new theory of gravity is needed, what kind of theory would it be? How could it correctly describe the motion of the bodies in the solar system, as Einstein's theory is known to do, and still give us the different prediction for the universe that we need? There are candidate theories, but none are compelling. So the mystery continues. It's also possible that dark energy doesn't exist and something strange is going on with gravity. Modifying gravity allows for all sorts of weird possibilities. One theory incorporates a higher dimension that gravity can extend to but we can't directly access. This dimension can influence ours, and interactions can produce effects like cosmic acceleration. Revising gravity is no easy task. Einstein's theory of general relativity has proven to be incredibly accurate, and attempts to rewrite his equations have been largely unsuccessful. Trying to fit cosmic acceleration into these equations makes them unable to explain well-understood phenomena, such as how the moon revolves around the Earth. Scientists have extensively tested Einstein's theory, but they are just beginning to investigate it at the enormous intergalactic scales of dark energy's effects. If scientists find inconsistencies, they will have uncovered signs of new physics. If the only way we could interpret the discrepancy was that something strange is going on with gravity, we'd be pointed in a whole new direction in fundamental physics, says astrophysicist Josh Freeman, director of the Dark Energy Survey, an experiment aimed at finding the cause of cosmic acceleration. Because modified gravity models fall into uncharted territory, they make the fate of the universe more difficult to predict. To do so, scientists will first need to better understand how it works. In the quest to understand dark energy, the initial tasks are to determine whether it actually exists and to test whether it fits with the idea of the cosmological constant. To do this, scientists are studying the history of the universe's expansion as well as the growth of galaxies and other structures. Gravity and the cosmological constant make very specific predictions about what they should see, so finding discrepancies can help rule out some of these theories. However, eliminating possibilities doesn't necessarily mean an answer is near. Don't forget to comment. What do you think is the dark energy, real or another fake story made by our curious minds? The ultimate fate of our universe is a question humans have been pondering since the earliest civilizations. The answer might not be around the corner, but we're certainly closer than we've ever been before. There are lots of questions left, so don't space out, and leave some space in your brain for answers. I hope you enjoyed this video. If you want to see more, subscribe and click the bell button, to get notifications on our latest videos. If you are still here, grab your knowledge and get out of my train.